You get my point? Because I include all the formulas in the slides. Suppose if any formula is missing, please kindly include that formula. So this is just for your reference. If you just, before you come for the exam, if you just want to recall all the formulas, that's what I just prepared, and then I just uploaded in the Blackboard yesterday. Okay, we just start our today's session. Okay, no problem, brother. It's my pleasure to give you. If you got good marks, really, I am the first person to get more happy. Okay, I'll just share my file. Okay. Today, we are going to discuss chapter 11 regarding the rolling of an object. What is the torque calculation? Because we already studied the concept for torque in chapter 10. And then the new topic is angular momentum. If you just go to chapter number 9, we studied the concept of linear momentum. Am I right? What is the formula for linear momentum, brother? Could you please recall the formula for linear momentum? Linear momentum is P, which is equal to M multiplied by V. Am I right? Am I right?
Yes, you're right.
Okay. Now, in this chapter, we're going to study the rotational momentum, which is called as angular momentum. I told you already, whenever you just come for the concept of rotation, if you just replace, you will get the formula. For example, this P should be replaced with the letter L, because L stands for angular momentum. If you replace this M with moment of inertia, I. If you replace the linear velocity with the angular velocity, it's omega. So this will be the formula for this angular momentum. So we have two formulas for angular momentum. So especially in this chapter, the most important thing is this angular momentum, and we have some questions also. So please listen the class, and the remaining topic is exactly same like what we discussed in the chapter 10 rotation. Okay, first slide. Rolling as translation and rotation combined. In the last chapter, we studied about the rotation. Am I right? If any object is under rotation, it must have two types of motion. First one is translation motion, and the second one is rotational motion. For example, you can take an example of the wheel. If you take a wheel from your car, the wheel is rotating. Am I right? So the wheel is rolling. When you are just about to drive the car, your wheel is rolling over the road. Am I right? Am I right or not?
Yes.
So we are just going to study the concept. If any body is rolling, it must have two types of motion. The first one is translation, second one is rotation. If you just take an example of translation, the most important thing, the kinetic energy. Because when you just come for translation, we already studied the formula of the kinetic energy, which is nothing but half m v square. When you come for rotation, half I omega square. So these two formulas we already studied in chapter number 10 in the last week. Am I right? So if you just see the formula, this formula is for pure translational kinetic energy, and this formula is for pure rotational kinetic energy. So these two formulas we are going to use for solving the problem, and also we have one more problem for this chapter. Once we finish the theory, then we are just going to finish the problem from this chapter. So if you just see the information from this slide, if any object is under rolling, it must have two motions, which is nothing but translation motion and rotational motion. Now, if you just see the picture, here a disk is rolling, and the disk has some center of mass. Just to see the center of mass. So if the disk is rolling from this point to this point, first of all, it is moving in a straight line. So if you just see here, it is moving in the straight line from the top, center, and bottom. So this is nothing but our translation motion. At the same time, the disk is rolling, so it must have some rotational motion. So for a straight line moving, you have the kinetic energy half mv square. For the rotational, you have half I omega square. Now, if you just see this box, what is given here? The center of mass of a disk moves forward in the pure translation motion. The point on the rim of the disk traces out a curve or a cycloid. You can just see here, when the disk is about rolling, it just forms some traces. So this is called as cycloid. So when the disk will be more rolling on the surface, what will happen? It will just make this type of traces, and that traces is called as cycloid. So if any object is rolling, it must exactly focus on its center of mass. We already studied the concept of center of mass in chapter number 9. Am I right? Okay. Let's we just come for this slide. This slide also tells you something about the relation between the linear as well as the rotational. That means if you just see here, we consider only object that rolls smoothly. That means there is no friction, there is no slipping. That means an object is rolling on the surface smoothly. When it's just rolling on the surface very smoothly, what are the information you are going to get? The first thing about the center of mass. The center of mass of an object moves along a straight line parallel to the surface. For example, you can see here this picture. This wheel is rolling, so our center of mass of the velocity will be in this direction, and it is exactly moving in the parallel direction to the surface. And the object rotates around its center of mass as it moves. So COM stands for center of mass. So if any object is rotates, it will be exactly rotating about its center of mass. And we already studied the relation of rotational parameters with the linear parameter. It is nothing but S is equal to R theta and our linear speed, which is equal to R omega. So we studied three relations. If you just recall, this is our angular, this is our displacement with the angular displacement. That means S is equal to R theta, V which is equal to R omega, and A which is equal to R alpha. So the displacement is related as R multiplied by angular displacement, and our linear velocity is equal to the radius multiplied by angular velocity, and the linear acceleration is equal to radius multiplied by angular acceleration. Now, if you just see, I already explained these things in the last class. So if any object is rotating, it must have pure translation, pure rotational. Now you can just see where the speed will be in this disk. For example, you consider this is a disk. If this disk will be rolling on the surface, it must have speed on 3 points. What are the 3 points? It will have some speed at the top, and it must have some speed in the center, and it must exactly speed in the bottom. But all these will be moving, all this velocity will be only in the same direction. That means the straight line. That's what we are just saying. It's a translation. When you just come for the rotational point of view, if you just see the picture, the speed at the top will be in the right direction, and the speed at the bottom will be in the left direction. If the wheel is rolling in this direction, there will be no speed at the center. Now, for example, if you just combine these two diagrams together, you can see here at the top of the rotational, I have the speed, I have the velocity in this direction, and here also I have the same direction. So when you just add these two, its magnitude will be greater at the top. You can see the length of the arrow mark. If you just add the center of the rotational as well as the center of the translation motion, here there is no velocity, but here we have velocity. If you just add these with this, you'll get the same amount of the velocity which has in the translation motion. Now when you just come for the bottom, in the rotational, it has in the opposite direction, but in the linear, it will have the direction straightward direction. Am I right? When you just add these two, this velocity will cancel this. There will be no speed at the bottom. So what you understand from this diagram, if any object is under rolling, it has more speed at the top of the wheel. In the center of the wheel, it will be exactly half of the top, but in the bottom, there will be no. So every time it will be keep on rolling, especially based on the high speed at the top of the wheel. That's what I just written here. The wheel moves faster near its tops than near its bottom. So all the times when you just see the wheel top side has more speed. So if you just see the relation, we already know V which is equal to omega multiplied by R. So here you can just see only the top side. So if you just see here, I have one speed here, I have one speed here. So how many just times you have? You have 2 times of the R. So when you just multiply these two, 2 multiplied by omega R, then our omega which is equal to V, because we already studied the relation V is equal to r omega. So this is the relation. When you just study the concept of rolling motion, you have to just immediately get this point. If any object is under rolling, it must have Q rotation as well as Q translation. Understand, brother?
Yes, teacher.
Okay.
Yes.
Now, again the same formula. So we already studied the kinetic energy of the rolling body. It must have the translational kinetic energy. It must have the rotational kinetic energy. Translation kinetic energy, half mv square. Rotational kinetic energy, half I omega square. So where we got this formula? By using the parallel axis theorem. When you are just using the moment of inertia, when you just study the concept of moment of inertia, you will study two theorem, parallel axis theorem, perpendicular axis theorem. But this theorem is not given in our syllabus, so don't worry. By using this parallel axis theorem, when you just work out with this formula, finally you will get the kinetic energy of the rolling body as half mv square plus half I omega square. So from this slide, you just keep the information in your mind. What is the kinetic energy of the rolling body? The kinetic energy of the rolling body, it's the combination of translational kinetic energy plus rotational kinetic energy. That information is given in this box. So this information I just take it from the book. What is written here? The rolling object has two types of kinetic energy. Rotational kinetic energy half I omega square due to its rotation about the center of mass. Every time you have to concentrate on the center of mass. When you just come for the translation kinetic energy, it has half mv square due to the translation at its center of mass. Every time based on the center of mass, the object has its kinetic energy. Now, when any object is rolling, what should be its acceleration? Because previously we are just studying the concept of velocity. Am I right? So in this slide, we are just going to study the concept of what is the linear acceleration with the rotational acceleration. Because we already studied linear acceleration is A, or tangential acceleration, which is equal to R multiplied by our angular acceleration alpha. So what is the angular acceleration? If any object is rolling, what should be its acceleration formula? Now, if you just see here, I just gave one picture and we are just calculating the acceleration of this diagram. What is given in the diagram? You have an inclined plane and you just keep one disc at the top and you just make the disc rolling from top to bottom. And the topmost side of this inclined is positive x-axis and the bottom inclined is nothing but our negative x-axis. Now, what is the condition? While the disc will be rolling, it should not be slipped down. It should be rolling smoothly. So when it is rolling smoothly, what will happen? There are some force acting on that body. That information is given here. What is given here? For smooth rolling down the ramp, the gravitational force is vertically down and the normal force is perpendicular to the ramp. We already studied this concept in chapter number 5 when you just study the concept of free body diagram. If any object you have, so this object have some force, the force will be exactly happen on that object based on the resting condition, based on the moving condition. So here the diagram gives you the disc is rolling in the inclined plane from top to bottom. The top of the inclined plane is considered as positive x-axis. The bottom of the inclined plane is considered as negative x-axis. Now from the top to bottom, the disc is rolling. When the disc is about to rolling, there are many forces which will be exactly happen on that body. So what are the forces we have? You have the normal force, you have the downward force, which is nothing but force due to gravity, and based on the acceleration and based on the center of mass, you have two components, x component and y component, so which is nothing but f cosine theta, f sine theta. But generally the disc will be accelerating only in the sine component. So if you just see the picture, there will be no acceleration in the cosine component, only the acceleration in the sine component. So we are going to consider only the sine component, and while the disc will be rolling, the most important thing, the friction force will be here. Because what condition we are just saying, only it is not slipping down. So only the object is rolling from the inclined plane from top to bottom, what will be the acceleration? So if you just calculate, we got the formula of acceleration in x-axis, it is equal to minus g sine theta over 1 plus inertia over mr square. Now how we got this formula? The explanation is given in the second slide. So what are the conditions? So if you just see, I'm just consider only the x-axis direction. So I'm going to apply the Newton's second law, F which is equal to m multiplied by a, that means acceleration based on the x-axis. Now if you just see, I'm just showing the forces which is exactly acting on the rolling body. So this is our normal force, and this is our force due to gravity based on the two components. This is our cosine component, this is our sine component. At the same time, the disc has some radius r, and the friction will be here, and the acceleration of the wheel will be in this direction. Understand, brother?
Yes, Doctor.
Okay. Now come for the concept. Now, based on the force acting on the body, I'm just using the equation. So which direction the object has the acceleration? The object has the acceleration only in the sine component. So when the object is rolling, it has some friction force also. So I have to write my right hand side force, which is equal to left hand side. So my right hand side force is a frictional force. My left hand side axe force is nothing but Fg. Fg is nothing but mg sine theta, which is equal to our Newton's second law, mass multiplied by acceleration. Now, what we are going to do, the most important thing, we are going to find what should be our frictional force. So for finding the frictional force, I'm going to apply the torque concept. Brother, in chapter 10, we studied two formulas. What are the two formulas? Torque, R is exactly perpendicular to force. And also, we studied the formula for torque tau, which is equal to I multiplied by alpha. What is our torque? Our torque is the rotational force. So if any rotational force you must have, you must need the radius as well as the force, and these two will be exactly perpendicular. That's what we are just using torque tau, which is equal to RF sine theta. Do you remember this formula?
Yes, what is sine theta?
Because here it's exactly perpendicular. You can see the diagram. This is our R. Am I right?
Yes.
So this is our frictional force. What is the angle?
1 minute.
What is that?
90. 90.
90. So sine 90 becomes 1. Am I right?
1, yeah.
So that's what I just write. R multiplied by Fs, which is equal to my another formula for the torque tau, which is equal to I alpha. We studied this formula. Do you remember this formula? This is the formula between
And
the
the
relation of
chapter 10.
torque as well as alpha. In chapter number 10, we study this rule. So if this will be having some value, so I can just equate with I alpha. Am I right? So where we got this? We just use our frictional force, which is exactly perpendicular to the radius of the disc. So 90 degree, sine of 90 degree becomes 1. So I have only R multiplied by frictional force, which is nothing but my torque, which is equal to my torque, which is equal to I alpha. We already studied this relation in chapter number 10. Now, what we are going to do, I'm going to replace this alpha with this relation. We already studied the relation between the linear acceleration with the rotational acceleration. So therefore, my alpha, which is equal to A center of mass over R. Am I right? So I take this alpha, I'm going to substitute here. When I just substitute here, I got the acceleration. I got the acceleration like this. Am I right? Am I right? Once you substitute this alpha here, what is your frictional force? So rearrange this equation. Rearrange this equation. After you substitute the value of alpha, I got the value of frictional force like this. Am I right?
Yes, teacher, you are right.
Okay, now after I found the frictional force, what I'm going to do, I'm going to take this frictional force, I'm going to substitute here. When you substitute here, you will have some mathematical rearrangement of the equation. So you have to rearrange the equation. So moving some terms from left hand side to right hand side. The most important thing, we are just going to find the acceleration of the rolling disc from the top to bottom of the inclined plane. So when you just rearrange the equation, after you substitute the frictional force in the given equation, you will get the acceleration value as minus of g sine theta over 1 plus moment of inertia of the center of mass over mr square, and that formula is given here. So how we got this formula? By applying the torque concept in this picture, and after we are just rearranging this equation based on the free body diagram, we got the answer of acceleration of the disc for the rolling body from the top to the bottom of the inclined plane as A, which is equal to minus g sine theta over 1 plus I over mr square. So this is the explanation how we got the formula. Yes, brother.
Doctor, from where we got 1?
What, brother?
From where we got
brother, this is
1.
mathematical. Brother, listen carefully. Take a paper, okay? I will tell you the picture, okay? First you write this equation. This is our first step, okay? Understand?
Yes. Understand.
And then second, I'm going to use these three equation, okay?
Okay.
And then I'm just applying the torque. So first point is this, second point is this, and then by using the principle of the torque, I got this relation. And now the fourth point, I'm just going to take this value. So that means from this equation, I'm just calculating this alpha. So this is my 4. After I find the 4, I take the 4 and I'm going to substitute here. Okay. Better I can just erase everything and then I will tell you the clear picture. Wait. What is our first step? The first step, we have to write the equation, okay, based on the free body diagram. And the second thing, I apply the torque concept. I write this equation. So this is our second point. The third point, from our relation between the acceleration, linear acceleration and the angular acceleration, I find the value of alpha. Therefore, alpha, which is equal to A center of mass over R. So this is our third point. So after I find the third point, I'm going to take this third, I'm going to substitute here. So while you substitute here, you will get this fourth point. Okay.
Okay.
And after you got the fourth equation, what I'm going to do, I'm going to take this fourth equation, I'm going to substitute in this equation. When you just substitute in this equation, you will get this answer. Now your question, doctor, where we got this one, am I right?
Yes.
So this one, while you just substituting the value of Fs in the first equation, you have to do some rearrangement of the equation. When you just rearrangement of the equation, you will get the answer. Okay, I can do one thing. I will just work out this equation. I will put that page in the slide. Okay.
Okay. Thank you, doctor.
I have the copy. But I just take these things. We are going to lose many time because it's some explanation will be there, some derivation, some equations will be there. If you need the information, no problem. I already have the answer. I will just take the picture and then I will just paste it in the slides. Okay. But the most important thing, we are going to use this equation for finding the acceleration of the rolling body. Okay. Understand?
Okay. Understand. Thank you, doctor.
Okay, welcome. Okay. Now, the most important topic from this chapter is related with the angular momentum. Brother, in chapter number 9, we studied the concept of linear momentum, P, which is equal to M multiplied by V. Now, in this chapter, because this is our linear momentum, this is our rotational momentum. So, the concept of rotational momentum, whenever you have the concept of rotational momentum, you have some momentum and which is related to our rotational. So, when you just come for this rotational angular momentum, you have two formulas for angular momentum. The first formula is L multiplied by R cross P, and the second formula is L is equal to I omega. So when we are going to use this, brother, you can see the picture. It's a point object. If your object is very small, okay, if this object is under rotation, you have this rule. So what is our rule? For example, you can see this diagram. I have a small mass and this mass is under rotation, and this mass is rotation means it must have some radius R. Am I right?
Yes, doctor.
Right? And this object has some mass, and when the object is rotating, it must have some velocity. That means the tangential velocity will be there. That means when the object will be here, this will be our velocity. When the object comes here, this will be our R, and this will be our velocity. When the object comes here, this will be our R, this will be our velocity. When the object comes
almost
here,
perpendicular.
What, brother?
Almost perpendicular.
Always perpendicular to the center of rotation. So we already studied our velocity is exactly perpendicular to the acceleration. So if you have any point object, we have to use this formula. What is our formula? R cross P. That means R multiplied by P. Why we are just using P? Because this object has some mass and also this object some velocity. So what is the formula of MV? MV is nothing but our, what is MV?
Momentum.
It's a linear momentum. That's what we are just using R cross P. Understand, brother? So how I can write? I can just write this R cross P as R cross P. So M is the constant. So I take it outside. So how I can write? I can write M R cross V. I have to write. Clear?
Doctors, what's mean L here?
L is the angular momentum. L is called as angular momentum.
To find the angles.
Yes, angular means the object is under rotation. Keep this information. Understand? Not related to
Okay.
the angle. The object is under rotation. Angular means any object, if it is under rotation, it must have some angular parameter, angular
What is
displacement.
anger? Could you please show the angers
What
and
is
the screen? The angers in this photo.
What is anger? Anger. What? Brother, the
Anger,
object is brother. Angular means rotation. I said rotation, not anger. Anger is a different word. When the object is under rotation, you have to use the word angular.
okay.
Clear? So now just see here, brother. What is the angle between the V and this R? It's exactly. What is the angle between the R and V?
It's equal to
90.
It's exactly. You can see. Speed will be this. Am I right? Now, what is this angle? Our angle is
90.
exactly 90 degree. That's what, if you just have any cross product, how you have to write, because we already studied in chapter number 3, A cross B, which is equal to AB sine theta. Likewise, R cross B, which is equal to RB sine theta. And we have M here outside. So how I can write? I can write my angular momentum, which is equal to R MB sine theta. Clear? Clear?
Yes, teacher. Clear.
Okay. Okay. Now, what is the unit? The most important thing is unit. So, what is the unit? The unit for meter, the unit for mass is kilogram, the unit for R is meter, the unit for velocity is meter per second. So, what will be the unit for the angular momentum? The unit for the angular momentum is kilogram meter square per second. Another unit is nothing but joules second. Clear, brother? Because kilogram meter per second, meter square per second is called as, which is equal to joules second. Understand, brother?
Yes, teacher.
Okay. Now let's come for the Newton's second law form of angular momentum. Brother, in chapter number 9, we studied the Newton's second law for linear momentum. Do you remember that? How we got this formula? I'm just using the Newton's second law. What is our formula? F, which is equal to m into a. I'm just explaining for the first equation. So F is equal to ma. What is our acceleration? Instantaneous acceleration. We already know a, which is equal to dv over dt. Am I right? Am I right or not? No response, huh? I don't know whether the students are in the classroom or they are sleeping.
Yes, teacher. We are with
Every time I'm just hearing the sound of Mr. Bazam and Abdullah. Remaining all students, you are sleeping, huh? What happened to you, brother? Huh? Just simply turn on the screen and then sleeping, or just, I think most of the students, I think you are not in the class. Simply log in and then they left. Am I right? My dear, listen carefully. Listen, my friend. I have no issue. You are inside the classroom or outside the classroom. I have no issue. As a teacher, I will just cover my syllabus. And finally, when the final exam came, you are going to fight with the paper. That's it. At least you can see your midterm paper. If you are just getting very worst mark in the final exam paper, you have to pay some money. Am I right?
yes.
You can't be able to see your paper. That's the most painful thing. Understand? Teacher will ever regrade your paper and then again they will tell you the mark only. You will not see you can't be able to see your final exam paper. So please listen the class carefully. If you have any doubts, please open your mouth and ask your question. Teacher asks you any question, please open your mouth and give your answer. This is the only information I need from your side. Clear?
Clear.
Okay.
Clear.
Okay. The first equation, Newton's second law form of linear momentum. So how we got? I am using our Newton's second law, F which is equal to ma, and we know the instantaneous acceleration, a which is equal to dv over dt. So I take this, I'm going to substitute here. If you substitute, what you will get, brother? I will get m dv over dt. Am I right? So now our mass is the constant. I can write this equation as d of mv over dt.
Momentum. Yes.
Am I right?
Yes, and
What is
this
this,
momentum.
So mv, which is nothing but momentum. If you just take and replace this mv with p, what you will get? My net force, which is equal to dp over dt. We already studied this equation in chapter number 9. Now this is for the linear Newton's second law of motion with a linear momentum. But now the most important thing, we are going to only concentrate on this. So what is the form? How we got this? Because we are just going to get the rotational force, which is equal to, that means the torque, net torque, which is equal to rate of change of angular momentum. So how we got? We got the relation by using these type of steps. Better I can just do it one more time. We already know the form. What is our linear momentum? What is our angular momentum? L, which is equal to m r cross v. Am I right?
Yes.
Okay. Now what I'm going to do? I'm going to differentiate these two because this is our UV form. I think you already studied in calculus. How you just differentiate? U dv plus v du. Have you studied this formula?
Yes, yes. The derivative of.
So I'm going to apply this UV differentiation inside. So how I can write to that? First I'm going to keep my R and then I'm going to differentiate this V. So M is a constant. I take it outside. So first I'm going to keep the R. I'm going to find the derivative. What is our derivative? Which is nothing but dV over dt. Am I right?
Yes, you're right.
And then second part, I'm going to keep this V as constant. I'm going to find the derivative. So what is that? dr over dt, which multiplied by v. Am I right?
Yes.
Now you can see, brother, I am just extended this equation, which is nothing but m r dv over dt. I can just write this is as my acceleration. Am I right?
Yes, because V
Yes,
over.
and this one, what is dr over dt? My dr over dt is also v, and this is also v. Now you can see, brother, here I have a cross product, and here also I have cross. Am I right?
Doctor, why V? It's A acceleration. dV over dt.
dv over dt. You already studied in chapter number 2. Do you remember
Yeah,
this formula?
I know that, but you write here V.
Where I just write v.
Here. In
First part or
the
second? First part or second part?
second part.
Second part, brother. This is R. This is not V.
Sorry. I
Okay,
think,
so my handwriting is very worst here. So dr over dt, which is nothing but my
this
V. Am I right?
velocity, yeah, yes, you're right.
So now, what is the form for V cross V?
Zero.
Equal to 0, because
Zero.
we studied this concept in chapter number 3. I cross I 0, J cross J 0, K cross K 0. Am I right?
Yes, you're right.
Okay, now you can see I can just take this term as 0, this term as 0. Understand? Now what is remaining? M R cross A. Am I right?
Yes, you're right.
Am I right or not?
Yes, you're right, doctor.
Okay, now what is MA? So I can just move M to here. So what I will get? So I can write R cross MA. Am I right?
Yes, you're right. Because
What is R cross MA? What is this MA?
momentum.
Brother, what is MA?
Oh, sorry. Force.
So I have, so if I just differentiate this is L over dt, because we just differentiate this term, everything with d. Am I right? So left hand side dl over dt, right hand side r cross f. What is this r cross f? We already studied the torque tau, which is equal to r cross f. Am I right?
Yes, you're right.
So that's what we are just writing for net torque, which is equal to dl over dt. Brother, sometimes you may ask one more question. Write down the Newton's second law form of linear momentum and write down the Newton's second law form of angular momentum. So what you have to do? You have to give these two answers. Clear?
Yes.
Okay. Now let's come for our last topic, conservation. Brother, this is just a summary of our linear and rotation. So let's come for our last topic, conservation of angular momentum. What is the meaning for conservation?
Keeping.
Conservation, like keep.
Initial momentum, which is equal to final momentum. Am I right?
Yes, you're right.
So we are just studying the concept we are just studying the concept of angular momentum. So my initial angular momentum, which is equal to final angular momentum, we already know because we have two formulas. What are the two formulas? You can see here, we have two formulas for angular momentum. One is for small object, second one for extended object, big object. Am I right? When you just have a big object, what is your momentum formula? L, which is equal to I omega. So L is equal to I omega. Brother, just read the question. If the question is related with a bigger size object, you have to use this formula. Okay.
Okay.
Okay. Now you can just come for the conservation. I have this picture. I'm going to apply the angular momentum for this, and I'm going to apply the angular momentum for this. This is my initial. This is my final. So now you can see our body is our big size. So when any object is under rotation, you have initial angular momentum, and after rotation, you have final angular momentum. The most important thing is your radius. Brother, this is your center of axis. So the person is sitting on the rolling chair. He is holding two dumbbells on his hand, and you can see this is my axis of rotation, and he is holding the dumbbell at some distance. This is our R. Am I right?
Yes, you're right.
Now you can see here, we are just about to rotate this person. The person is about to rotate. He will just keep on rotating. Now what this person is doing? He is just decreasing his radius. You can see this picture. He's just decreasing his radius. When he is about to decreasing his radius, what will happen? His rotation will be increased. Keep this point in your mind. Even you can experience. You can just do this experiment in your home. In our home, we have a rolling chair. Am I right?
Yeah.
Okay, you have a dumbbell because many students are doing the exercise. Am I right?
Yes, you're right.
Okay, hold two dumbbells on your left hand side and the right hand side, and please ask your brother to rotate the rolling chair. When you are about to rotate, what you have to do? While rotating, you have to decrease your radius. That means you have to bring the dumbbell closer to your body. Whenever you are just bringing the dumbbell closer to your body, your rotation will be increasing. That concept is given here. Clear?
Here, doctor.
Okay, brother, have you finished the moment of inertia? Finish the moment of inertia experiment.
Yes, we finish with you, doctors.
Okay, you finish moment of inertia. Okay, in the second table, you just make the R value. Do you remember that? R is equal to 5 centimeter, 10 centimeter, 15 centimeter, 20. Do you remember that?
Doctor's experiment number 7.
Brother, I'm asking this question only for those who finish moment of inertia. Experiment number 8.
Oh, sorry. I think 7.
Some students, I think you are going to do this experiment by this week. Am I right? Those who already finished experiment 8 already finished the second table. When you just come for the second table, you are fixing the R value. Am I right or not?
Yes.
Okay, now you can see when your R value is 5, just calculate the time taken. Am I right?
Yes. Because it's
okay. Okay, listen. Still, I have not completed the question. Your R value will be here. When your R value will be 5, what should be your time? When your R value will be 30, what should be your time? Which time will be more?
That's the second one.
When you make R is equal to 5 centimeter on left hand side and the right hand side, what should be your time? When your R value will be 30 centimeter, what will be your R? What will be your time period? Wait, I can just show you the picture. I think those who finish this experiment, wait a minute. I can just show you then only you will get a clear idea. You finish this table, am I right? Okay. Now, when you put this R value as 5 centimeter, take the time taken, am I right? You can observe. When you put 5 centimeter, your oscillation will be very quickly, am I right? When you just put 30 centimeter, what happened to your oscillation? It will be, that means your time taken will be more, am I right?
Yes, doctor.
The same concept is here. When you just see the picture, when you make your radius smaller, the rotation will be very quick. When your radius will be more, your rotation will be taking more time. So that is the most important thing. But the concept concept, we are just using the angular momentum. That means the initial angular momentum must be equal to the final angular momentum. What is the formula for initial angular momentum? I1, I, omega I. What is our final? I final, omega final. Clear? Okay. So that's
Yes,
it. Your chapter is over. What are the things today we discussed? We discussed the formula of angular momentum. Am I right? L which is equal to I omega and L which is equal to R cross P. We have these two formula for the angular momentum. Apart from that, we are just using some concept which we studied in the chapter number 10. So based on this, we are going to solve 5 problems, and these 5 problems are very easy. Clear? Understand?
yes, yes.
Okay.
Teacher.
Let's just start. First question. What is given in the first question?
We're given the V.
What, brother?
We have a radius.
And the velocity.
Yes. And it says
You are talking about the question. Am I right? Okay. Read the question. What is given here? I will just read line by line. You can just get the clear picture. A solid ball of radius 6 centimeter. That means the ball radius is given. What is the value? 6 centimeters. So I converted to meter. And it is initially rolling smoothly at a 10 meter per second. So what is its speed? Its speed is also given. What is its speed? 10 meter per second. It then rolls smoothly up a ramp. That means you can see the picture, brother. The picture. So your ball will be rolling, and after some times, what happened? The surface will be like this. So the ball will be rolling smoothly on the surface, and after some time, what will happen? It will reach this type of structure, and now the ball will be rolling like this. Am I right? Am I right or not?
Yes, you're right. Yes.
Okay, now listen here. The ball will be rolling on the horizontal surface. It will be going with some speed. What is our speed? 10 meter per second. And what is the radius of the ball? The radius of the ball is exactly 6 centimeter. Now, when the object is reaching this ramp, it will go to some maximum height, and after that it will be stopped. Right?
Yes, you're right.
Yes, you're right.
So we are going to find how much height the ball will just reach. So this is our question. We are going to find the value of height. So what we are going to do? We are just going to use the conservation of kinetic energy because the ball is rolling. So brother, listen carefully. Kinetic energy, which is equal to potential energy. So when the ball is rolling here, the kinetic energy is going to decrease. When the ball comes to this point, for example, this is my point A, this is my point B. When the ball is at point A, you have kinetic energy. When the ball comes to point B, you have more potential energy, but your kinetic energy is going to decrease. Am I right? So how I can write? I can write loss in kinetic energy, which is equal to gain in potential energy. Am I right?
Yes, yes.
Yes, you're right.
The formula, because we are talking about the rolling object. That means you have two kinetic energy. What are the two kinetic energy? Half I omega square for rotational and plus half mv square for the linear. Am I right or not?
Yes, you're right.
And what is the formula for potential energy? We already know the formula mgh. Am I right?
Yes.
Now, if you just see this picture, the most important thing, they are just giving you the information about the solid ball. Brother, here I can just have different type of picture. So what is your solid ball? Your solid ball is nothing but solid sphere. Am I right? So this is your solid ball. Am I right?
Yes.
Okay, now we have to use this moment of inertia for here. So what is our moment of inertia for the solid? 2/5 mr square. So in this place, I am going to substitute the value of solid ball, value moment of inertia, half. What is our value of I? 2/5 m r square. And what is our omega? Our omega. Brother, what is the relation connecting linear speed and the angular speed? R omega. Therefore, omega, which is equal to V over R. Am I right?
Yes.
Yes.
So in this place, I'm going to substitute this value. So what I will get? V square over R square. Am I right?
Yes, doctor.
Okay, plus half m v square, half m v square. I'm just writing this term as it is, which is equal to mgh. Now you can see here, brother, my left hand side also have the mass, right hand side also have the mass, so I can just cancel this mass. Am I right?
Cancel, yeah.
What, brother?
Wait.
Doctor,
happened?
from all, you cancel the mass.
Yes, I'm just canceling because left hand side I have mass, right hand side I have mass, so I can cancel. Am I right?
Okay, but we have 2 mass.
Brother, I thought you are I thought you are genius, but you are just asking. Okay, no problem. I will explain. Okay, I can take mass here, common. Am I right? Okay,
Yes,
no need to cancel right now. I can take the mass common here. So if I take the mass common, what I have here, brother, half multiplied by 2 over m, 2 over 5 r square. Am I right?
Yes, you're right.
Multiply by v square over r square plus half v square. Am I right?
Yes, you're right.
Am I
No,
right or not? And here m.
Yes, right, I understand now.
Now I can just cancel mass with mass. Understand? Okay. Let's we just see the remaining term. What are the remaining term I can cancel? I can cancel these 2 with 2. Am I right?
Yes, you're right.
I can just cancel this r square plus r square. And what is remaining? I have 1 over 5 v square plus half v square, which is equal to gh.
Yes.
Okay. Here I'm going to take the LCM. So if I just take LCM, so 10, this becomes 2v square, this becomes 5v square, which is equal to gh. Am I right?
Yes, you're right.
So what is the total? 2v square plus 5v square? 7v square over 10, which is equal to gh. Am I right?
Yes.
Am I right or not?
Yes.
Is it clear?
Yes,
Brother,
doctor.
I take the LCM here. First here I take the LCM. When you take the LCM, I take 10 as the common. If you want to get 10, I have to multiply here with 2. I have to multiply here with 2. That's what I just write 2v square. Am I right?
Yes, you're right.
So it's 7v square over 10, which is equal to g multiplied by h. We are going to find the height only. Therefore, my height, which is equal to 7v square over 10 multiplied by g. Am I right?
Yes, teacher, you are right.
What is our v, brother? It's already given in the question. Our v is
10.
exactly 10 meter per second square. So 10 meter per second. So 10 square divided by 10 multiplied by our g value is 9.8. And you just work out with your calculator for 7.1. Understand?
Understand.
Yes,
My
teacher.
dear brother, one more small information. Listen, in your assignment, I asked one question related with the moment of inertia, and by that question, I am asking some different shape of the object. So what you have to do, you have to pick the formula for that shape to get the answer, because that question has more formula, that question has more mark. You know what is that question? I will just show you. This is your assignment question. I will show you, because I am going to give this question to you. Listen. Okay, see this question. See this question. What is written here? What is written here?
2 kilogram cylinder.
A 2 kilogram cylinder. What is the shape? Cylinder. Am I right?
Yes.
So if it is a cylinder, how to find the moment of inertia? Because you are going to calculate the angular momentum. You know the formula for angular momentum. Angular momentum, L is equal to I omega. but you need the value of I. So you can see the question here. We are just using the cylinder object. So what you have to do? You have to take the cylinder value. What is the value of cylinder, brother? You can just see this picture. You can see this picture. What is the value of the cylinder? What is the value of the cylinder?
CM equal MR square.
So here solid cylinder is nothing but half mr square. Brother, this formula I didn't give in the assignment question, but in the exam we will give the formula. Okay, understand?
Yes, understand.
My dear, please don't lose the mark, because if you made mistake in the moment of inertia, then your final answer will be wrong. So please read the question. What type of structure is given in the question? Then you have to use that particular formula. In the final exam, if any question is related with a different structure, we will give the formula. But this is your assignment. So for that assignment, I will not give the formula. You have to take the formula from the slides. Understand?
Understand, Doctor. Slow the slider. It's number 2, right? Here.
Yeah, this one. This formula you have to take half mr square.
Where? Here. You saw in the here, right?
For that assignment, you have to use this formula.
Yes, I said that. This second. Yeah, clear.
Clear? Half mr square.
Doctor,
Okay.
repeat why we take one kinetic energy as I multiplied by other mass multiplied by v square.
Because when the object is rolling, you have two types of kinetic energy. Am I right? You have two types of kinetic energy. Am I right or not?
Yes.
What is this? Half I omega square multiplied by half mv square. So this is for rotational. This is for translational. So if any body is rolling, you can see this is our surface. If any body is rolling, it must have the translation as well as rotational. Am I right?
Yeah.
That's what we are just using this formula.
Thank you.
Clear?
Yes, thank you.
Okay, that's good. So please, while you answer the question for your assignment, please be careful, brother. If you made mistake in the moment of inertia formula, then everything will be wrong. 2 marks I gave for that question. How many marks? How many marks?
2 marks.
2 marks. Please don't lose your marks. Understand?
Okay.
Okay. Let's become for. So answer is given here. So take a practice. So here this is for rotational. Better I can write here. This is for rotational. This is for translational motion. Okay. Clear? Your second question. What is given in the question?
In unit vector.
In a unit vector notation, what is the torque about the origin on a jar? Brother, don't worry about this word. Actually, this is a jar which contains some pepper. So don't worry about this word. So you have a jar and you are going to find how much torque you are just going to apply on this jar. So the coordinate of the jar is given. What is our coordinate? What is our coordinate? That means our position of the jar. That means this is the value of r. Am I right? What is our position vector, brother? R vector. Am I right? So our position vector
Yes.
is given as the coordinate. So what is that? 3 meter I cap
3 I cap
minus 2
minus
meter
2
j cap
m
4 meter k
4
cap. That means the position of the jar is given as a coordinate form. And you are just applying two forces. What are the two forces? F1. What is the value of F1? 3 Newton I cap minus 4 Newton J cap plus 5 Newton K cap. And what is your another force? Another force is minus 3 Newton I cap minus 4 Newton J cap minus 5 Newton K cap. Understand?
Yes,
You
teacher.
have a jar. That jar is on some location and its coordinates are given, and that coordinate is nothing but my position vector r. So what are the coordinates? 3 meter minus 2 meter plus 4 meter. That means 3 meter I cap minus 2 meter for j cap and plus 4 meter k cap, which is our position of the jar. And you are applying two forces. What are the two forces? First force is given as 3 Newton I cap minus 4 Newton j cap plus 5 Newton k cap. The second force minus 3 Newton I cap minus 4 Newton j cap minus 5 Newton k cap. But with help of this, what you are going to do, you are going to find the torque. What is the formula for torque? What is the formula for torque?
FR.
Formula for torque, which is nothing but R cross F. Am I right?
Yes, teacher.
So I'm going to apply this formula for two forces. First question. So first question, I'm going to apply the formula for the first force. So R vector cross F vector, which is equal to, you already know the method, I, J, K. Am I right? What is your value for I component? 3 minus 2
minus
4.
4.
And second force, that means the first, what is our first force?
3
minus 4 plus 5.
Plus 5.
Am I right? Now,
Yes.
what I'm going to do, I'm going to multiply. First, I for I cap, 5 multiplied by minus 2, minus 10. Am I right?
Yes.
Minus of minus 4 multiplied by 4, minus 16. Am I right?
Yes.
So I can just write my I. And the second j cap always negative. I told you already. So again, second 5 multiplied by 3, 15 minus 3 multiplied by 4, 12. Am I right?
Yes.
Of course, you are right.
And then the third one is plus k. Now minus 4 multiplied by 3, minus 12 minus of 3 multiplied by minus 2, minus 6. Am I right? Now, please,
Yes.
brother, use your calculator. If you don't know how to add, at least please use your calculator. Really, it's really pain for me when I just graded your midterm paper, because I graded this D1 cross D2 question. Do you remember that? One question we asked for D1 cross D2. Most of the students, you multiply everything perfectly, but you don't know how to add and subtract. So please do it very carefully. Okay, just tell me here, my I cap, which is equal to minus 10, minus into minus, 16. Am I right? Likewise, here j cap, plus 15 minus 12, 3. Am I right?
3.
Okay. Plus k cap, minus 12 is here, minus into minus become plus, which is equal to 6. Am I right?
Yes.
If you simplify, plus 16 minus 10, that means 6 I cap minus 3 j cap minus 6 k cap. Am I right? And what is the unit? Because here we are just making the force with the unit, the radius, Newton meter. Clear?
Clear.
Yes. Good.
Okay. Likewise, you have to do the torque for the second force. What is our second force? B, which is equal to R vector cross F2. Again, I am going to use the same method. I, J, K. What is my R value? 3 minus 2, 4. What is my F2? Minus 3, minus 4, minus 5. Now, you are just going to do the same thing. What you are going to do? I multiply by minus 5 multiplied by minus 2, 10, minus of minus 4 multiplied by 4, minus 16. Clear? Then minus of j cap, minus 5 multiplied by 3, minus 15, minus of minus 3 multiplied by 4, minus 12. Then the last one, plus k vector, k cap, minus 4 multiplied by 3, minus 12, minus of minus 3 multiplied by 2 plus 6. And then we are going to simplify. How to simplify? I cap 10 minus into minus plus 16 minus j cap minus 15 minus into minus becomes plus 12 plus k minus 12 minus 6. Clear? Understand? Now just add 10 plus 16, 26 I cap
26.
minus j minus 15 plus 12
minus 3.
minus 3 plus k minus
minus
16. Okay, now I can write 26 I cap minus into minus plus 3j minus 18k. What's the unit? Newton meter. Understand?
Understand.
Is it clear?
Clear.
Clear? Okay. This is the answer for the first two questions. What is your third question? Question.
The torque.
The vector sum of F1 and F2. What is your F1, brother? This is your F1. Am I right? What is your F2? This is your F2. Am I right? Then you are going to find the sum. So better I can just write here. What is your F1? My F1, which is equal to 3, 4, 5. Am I right? Okay. My F1, which is equal to 3 Newton I cap minus 4 Newton J cap plus 5 Newton K cap. Likewise, my F2. What is the value of F2? Minus 3, minus 4, minus 5. Minus 3 Newton I cap minus 4 Newton J cap minus 5 Newton K cap. Am I right? Vector sum. What is the meaning for vector sum? What is the meaning for vector sum? F1.
together.
We add them together.
Add together. Okay. Plus 3 minus 3, 0. Am I right?
Yes, you're right.
Right or not? Minus
Yeah,
4
yes.
minus 4,
0.
Minus
Minus 6.
Minus
Brother.
8.
minus 4 minus 4. How it will become
Sorry,
0,
sorry.
brother? Plus 5 minus 5, 0.
0.
Clear? So
Clear.
what is remaining? Only you have F1 vector plus F2 vector, which is equal to minus 8 Newton J cap.
Second.
That's it. Clear?
yes, teacher.
Clear? Okay. Now let's begin our fourth question. What is our fourth question? Just read the question very carefully. Read the question very carefully. What is your fourth question? Brother, wait. C question we find. Repeat part C for the torque. Okay. Again, we have to repeat part C. What is our part C? This is our part C. Am I right? Am I
Yes,
right or not? So we have to repeat the torque for the part C. So again, I have to find the torque. What is my torque? My torque tau is equal to R cross F. Am I right? So what is my F? My F is this. Again, I have to use the IJK method. So I, J, K. What is my R vector? What is my R vector? 3 minus 2, 4. 3 minus 2, 4. And force vector, I have only J component. Am I right? So what is my X component? 0.
0.
My Y
minus
component
8.
is 8. And my Z
0.
component is also 0. Again, the formula.
Sir.
I cap.
I don't understand about how we got. I know
Read
how
the
to
question.
join.
Brother, listen. Read the question. Question, the vector sum of F1 and F2. Am I right?
Yes, you're right.
Then fourth
Okay.
question, repeat part C. What is our part C? Part C is this. Am I right? Am I right?
Yes. Repeat part C with what?
Part C, you are going to find the torque with the position vector. What is the formula for torque? Torque is nothing but R cross F. So R is already given as a coordinate. What is our R? This is our R. Am I right?
Yes, you're right.
What is our force? Just before we find the force, what is our new force?
Oh, yeah, yeah.
Our new force
Yes,
is
yes,
this.
yes.
Am I right?
Yes, you're right. Yeah, yeah.
Okay, now apply the rule. So 0 multiplied by 0 is 0, minus of minus 8 multiplied by 4 minus 32. Am I right?
Yes, you're right.
Then j cap 0 multiplied by 3, 0. 0 multiplied by 4, again 0.
Zero.
Am I right? Then plus
Yes, you're
k,
right.
j cap minus 8 multiplied by 3 minus 24. 0 multiplied by 4 is 0. So no need to write. So what is here? Minus into minus becomes plus 32 I cap Newton meter. I can just write the unit later. J cap is 0. What is my K cap? 24 K cap. What's the unit?
Newton meter.
Clear?
Clear. It's easy, Doctor.
Okay.
It's a
It's
question.
easy, but you guys will make only the easiest question. I know. Okay. Okay. We have one. You can see the another question. What is given here? Repeat part C about the torque with a new coordinate. What is our part C, brother? Our part C value just before we find our forces 8. Am I right? And the new coordinate is given. What is our new coordinate, brother?
3i 2j 4k.
So our new coordinate, how you have to find? That's the most important thing. So our new coordinate D. What is our first coordinate? My first coordinate is given as 3 minus 2 plus 4. So that means 3 meter I cap. What is our first coordinate, brother? Minus 2 meter j cap plus 4 meter j cap. Am I right? What is the new coordinate? What is our new coordinate?
Can you
3
go?
to 4.
Yeah. 3 to 4.
So I can just take this is R0. So 3 meter I cap plus 2 meter I cap plus 4 meter K cap. Okay. Now you have two coordinates. What is the resultant, brother? The resultant vector, which is equal to this value minus this. Am I right?
Yes, you're right.
Okay. Could you please subtract? So this becomes 0. Am I right? 3 minus 3, 0. Minus 2 minus of 2. That means minus 4 meter J cap. 4 minus 4 again 0. So what is my new coordinate, brother? My new coordinate is only 4 meter J cap. Am I right?
Yes, you're right.
Now we are going to find the torque for this. What is our torque? Our torque, which is equal to R cross F, and this time my R is this, and this time my force is this. My force is this, because they clearly mentioned in the question. Okay, again play with IJK.
Doctor,
Yes.
they don't mention what is the dimension of the force.
Just read the question. Repeat part C for the torque about the new coordinate. What is our part C force? Our part C force is minus 8 Newton J. Am I right?
Huh?
Am I right or not?
Yes, you're right.
And our new coordinate is 4 meters. So again, I have to play with IJK. So what is my R value? My R have only J component. So X is 0. My Y is minus 4. My Z is 0. And my F coordinate 0 for X. My Y value is minus 8. And then Z is also 0. So now if you just play this with multiply I multiplied by 0 minus J multiplied by 0 plus J
0.
multiplied by 0. So what is the answer for the torque for the last question?
0.
0. That's it. Clear, brother? Read the question before you answer.
Inshallah, doctors.
Very good. Answers are given here. Take the practice. Brother, this is my kind request. Most of the students, you made a mistake in this type of question. So please multiply carefully. Adding and subtracting, you have to do it very carefully. Because I
Doctors,
already
please.
graded.
Doctor, please give this a question in final exam. Try to.
This type of question?
Yeah.
Inshallah.
It's very easy, doctors.
My dear, you are saying easy right now. But when the paper is given, Everything will be collapsed. May Allah make it easy for you, inshallah. Okay. Read the question. The question is a little bit bigger, but you have to think very carefully. Whether here the diagram is given in the top point of view. That means you are, because you are just having the picture in only in one-dimensional diagram. Am I right? But here you have to think the picture in three-dimensional point of view. If you just see the picture in three-dimensional point of view, you will get some idea. Read the question. At the instant of picture 1133, a 2 kilogram particle is at P. That means some particle is at exactly P. In this point, one particle is there. And its mass is given. What is that mass? The mass is given. What is that mass? 2 kilogram at point P. And it has position vector and its magnitude is given. What is its position vector? R. What's the value? 5 meter. And its angle theta 1 is given. What's the value of theta 1? 5 degree. And its velocity magnitude is given. What is its velocity magnitude? 4 meter per second. And its angle theta 2 is given because based on the diagram some angle is given, so which is 30 degree, and another force is acting, and that force magnitude is given as 2 Newton, and one more angle theta 3 is given in the picture, which is 30 degree. Now whether you can see the picture, all the three vectors. What are the three vectors? R vector is here, B vector is here, F vector is here. Am I right?
Yes, you're right.
R vector is here. You can see the picture. Only will get some idea. R vector is here, E vector is here, F vector is here. All the vectors are in XY plane, and the most important thing, and all these three vectors are exactly perpendicular. If you just see the picture from the top point of view, because I can't be able to draw the three-dimensional picture, so you have to think the picture from the top point of view. What is given here about the origin? What are the magnitude and the direction of the angular momentum? Brother, magnitude and angular momentum. First question, I'm going to find magnitude of the angular momentum. Angular momentum L, which is equal to R M E sine theta. We studied this formula, am I right? Because you have two formulas. What are the two formulas for angular momentum, brother? What are the two formulas for angular momentum? R cross P. Another formula is L is equal to I omega. Am I right?
Yes, doctor.
So if you just write this, how I can write? R mv sine theta. So if you can't use this because moment of inertia information as well as the angular velocity is not given, so I can't use this formula. I can use only the first formula. That's what I just write this. I'm going to substitute the value. Brother, listen carefully. We are just going to find the magnitude and the direction of the angular momentum. So please listen carefully. So R mv, m is the constant. R M, you can see the picture, brother, see the picture. R is here, M is exactly at the point, and V is this. Now you are going to use the R cross V. Which angle you are going to use? Angle you are going to use?
The second one.
So R value is 5, mass value is given as 2, B value is given as 4, sine of 2. Am I right?
Yes, and sine 30.
Sine 30. Oh, sorry. I can just write it. So here, sine 30. When you just multiply this, you will get 20 unit is kilogram per square per second.
Just that, doctor.
That's it.
Only this.
This is the first, because they are just need only the magnitude.
Oh, it's very easy.
Okay. What is your direction? Brother, when you come for the direction, you have to use your right hand rule. Brother, you have to pointed your finger. You have to pointed your finger in the direction of the R, and you have to curl your finger in the direction of V. What is your thumb finger? Your thumb finger will be exactly in the top. Am I right?
Yes, you're right.
You have to use your finger in the direction of R. I can't be able to draw my finger clearly. You can see, using my finger in this direction, in the direction of the R. Then I curl my finger in the direction of V. The direction of V. And where is my thumb finger will be there? My thumb finger will be exactly in the top. Am I right?
Doctors, how do you understand? Like,
Brother, actually, this question we can't be able to explain through. I don't know why doctor is choosing this question. Because when we are using the right hand rule, you have to show your hand in front of you. Then only I can just show you all these things. Without showing
Sir,
this,
you
I
don't have
can't.
camera to show how
Camera?
camera, yeah. Show
Okay,
show how
just a minute.
how
Just a minute. I can just turn on my camera. But camera, if I just show me where I can just show my finger, I can just show my R vector and V vector. Okay, brother, you can do one thing. You are in my theory class. You are in my lab classes.
yes.
You are in my lab classes. All.
For me, yes. I think
Okay,
so,
I can do one thing. If you just come to the lab classes, I will just draw the picture and then I show you by using my right hand. Because if I just open my camera, I have no issue to open my camera. But the problem, I can show only my finger, only my hand. Am I right?
yes, yeah.
Understand? But how I can just show the vector? I have to put my finger exactly over the vector diagram. So please don't worry about this question. Generally, for finding the direction, we have to use our right hand rule. We have to use our okay. Brother, listen carefully. Listen. This is our diagram. Am I right? We are using the right hand rule. Brother, are you on the line?
Yes, yes.
Okay. First, I just show my finger in the direction of R. You can see this is my R. And then I just turn my finger in the direction of V. Initially, I put my finger exactly in the direction of R, and then I turn my finger. That's what I just hold the finger like this. And where is my finger? This is my finger, thumb finger. Am I right? My thumb finger indicates the direction. Likewise, you can consider I put the fingers in the direction of the R, and then I turn my finger in the direction of the V. Where is my finger will be there? It is exactly in the upward direction. Am I right?
Yes.
So likewise, if you just see, all the pictures are exactly in the two-dimensional point of view, X and Y. So if you are just using this right hand rule here, if you just use the right hand rule here, just a minute. If you just use the right hand rule here, your thumb finger is exactly indicates your Z direction. Am I right?
Yes.
So what's the direction? Exactly showing. It's exactly showing opposite of Z direction.
Doctor, it's upward.
Upward, yeah.
Direction.
Brother, take a pen and then hold the pen with your finger. Just take a pen and hold the pen with your finger. So your thumb exactly upward direction. Am I right? Don't worry, brother. Brother, in exam, I think generally, brother, listen carefully. Generally, if you ask this question in the exam, most probably it will be the same type of question. So don't worry. If any direction is given in terms of this angular momentum, please mention you have to use your right hand rule. Understand?
Okay.
Okay. Now let's become second part. What is our second part? Again, you are going to find the magnitude and the direction of the torque. So what is our torque formula, brother? What is your torque formula? Torque tau, which is equal to R cross F. Am I right?
Yes.
Okay. So here I can just write RF sine theta. Am I right?
Yes, you're right.
Now you can see, brother, you have two more angles. Theta 1 is here, theta 3 is here, and we already studied your theta should be exactly 90 or less than 90. Am I right?
Yes.
Because if it is more than 90, because your theta becomes 180 and then it becomes 0. Am I right? So if you just see the theta 1, your theta, if you consider the theta 1, again it will be leads to, for example, if you just move this here in this direction, your both angles are exiting 90, 180 degree. Am I right? Okay.
Sir, about the theta 3.
Wait, that's what I'm just coming for that point only. Okay, see here. R, we are going to consider R and F. Am I right?
Yes, you're right.
Okay, now if your angle will be in this direction, what should be the angle between R and F? It will be more than 180. Am I right? 180. It will be closer to 180 degree. Am I right?
Yes.
Consider R and F. So if you just take your theta becomes 180, so theta 3 will not applicable. Am I right?
Because we moved the.
Because 180 will come, sin 180 becomes 0. And again, if you just move your vector in the direction of theta 1, again it becomes 180 degree. Your theta 1 will not come. Am I right?
Yes.
So which angle is here? Only theta 2 is perfect. Am I right or not?
Yes, you're right.
So how I can just write my R value is given in the question as 5 meter. My F value is given as 2, and my sine theta of theta 2 is equal to 5 multiplied by 2 multiplied by sine of 30 degree, which gives you 5 Newton meters. What is my torque, brother? My torque tau, which is equal to 5 Newton meter. Again, for finding the direction, you have to say we have to use the right hand rule. It will be exactly positive z direction because all three are exactly perpendicular. If you just see all the vectors from the top point of view, it is exactly perpendicular to each other. So what should be the angle or the torque? Because once the angular momentum will be in the positive direction, your torque will also in the same direction. Understand? So positive z direction. Clear? I will explain the right hand rule if you come to the.
Okay, thank you, doctor.
Okay, because in the online, if I can just open my camera, I have no issue. But where I can show the vector form, that's a very, very important thing. So if you come to the lab classes, I will draw and then I will just put my finger exactly in the direction of the vectors, and I can show the direction.
Okay, thank you, doctor.
Yeah. Okay, we come for our last question. This question is one of the important questions. Many times we ask in the final exam. So please listen carefully. First of all, try to understand what is given, and then try to write the given, and then try to apply the rule, and try to get the answer. Clear?
Yes.
Okay, read the question. The angular momentum of the wheel having the rotational inertia. What is inertia? I value. Am I right? So I value is given 0.140 kilogram meter square. About its central axis decreases from 3 to 0.8 kilogram meter square per second. That means its initial angular momentum. What is our initial angular momentum? Our initial angular momentum is 3 kilogram meter square per second. What is my final angular momentum? My final angular momentum is 0.8 kilogram meter square per second. Right? Right.
Right.
And within how much time? The time value is given. What is the time? It's exactly 1.5 second. Now, first question. What is the magnitude of the average torque? What is the magnitude of the average torque? We already studied this formula. Average torque, which is equal to delta L over delta T. Am I right? If torque net, which is equal to dl over dt, means what is my average vector? My average torque is delta L over delta T. Right?
Yes.
Okay, now what is my delta final minus initial? Am I right? Divided by my delta T. What is my final? My final is 0.8. My initial is 3. My 1.5. So your answer must be negative. Am I right? Am I right or not? Just open your mouth and give your answer.
Because it's of the.
Clear? So this will be the answer for the first question. Your second question, assuming a constant acceleration, through what angle does the wheel turn? That means you are going to find the value of theta. At what angle the wheel is turning? So what I am going to do for getting the second question, I am going to write our second equation. What is our second equation? Theta minus theta naught which is equal to omega naught t plus half alpha t square. Am I right?
Yes, you're
Am I
right.
right or not?
Yes,
Okay.
yes,
Now,
yes.
sir, you can see, is there any information about omega naught?
No.
No, I don't see.
Omega naught is not there, but we studied relation of angular momentum. What is our angular momentum? Our angular momentum L, which is equal to I omega. Am I right?
Yes, you're right.
So I can just write my L naught is equal to I omega naught. Am I right?
Yes.
Okay. Now what I'm going to do? I'm going to write the equation in terms of omega naught. What is my omega naught? My omega naught is nothing but L naught over I. Am I right?
Yes, you're right.
Okay. Likewise, we studied the relation connecting tau of the angular, the linear angular acceleration, tau which is equal to I alpha. We studied this relation in chapter number 10. Am I right?
Yes, doctor.
Therefore, alpha which is equal to tau over I. Am I right? Am I right or not?
Yes, teacher, you are right.
Okay. Take this omega naught, substitute here. Take this alpha, substitute here. So now you replace everything. Am I right? So if you just substitute here, what you will get? Theta minus theta naught, which is equal to, what is my omega naught? L naught over I multiplied by T plus half, my alpha is tau over I multiplied by T square. Am I right? Am I right or not?
Yes, yes,
Doctor,
you're right.
Now, L naught you have, T you have, I value you have, everything you have. When you just substitute, so your theta naught, initially it is start from 0. Am I right or not? So, when you just work substitute all the values here, you will get your theta value. Am I right? So, the answer for theta, better you can just take the paper and then work out. Right now, I am just writing only the answer. The theta after you substitute the value, 20.4 radian. Clear?
Clear.
Okay, what is the third question? How much work is done on the wheel? How much work is done? Brother, we already studied the formula for work done. Do you remember this formula? Work done, which is equal to tau multiplied by theta. Where we got? Because we already know F is equal to, W is equal to F multiplied by D. Alright? If you replace the force with the torque, you write tau. If you replace the distance with the theta, you have to write theta. So, we have theta value in the first, we have tau value here. What is our tau value? Minus 1.47. We have theta value. So we have two values in the previous question. So I can just take the value. I can substitute here. Minus 1.47 multiplied by theta is 20.4. So if you substitute the value here, you get the work done as 29.9 unit is joule. Clear? Okay, what is our fourth question? Fourth question, what is the average power of the wheel? What is the average power of the wheel? What should be the answer for the power, brother? What should be the answer for the power formula? We already studied this formula in the formula
W
power.
over T.
Power which is equal to W over T. Am I right?
Okay, doctor, but here he said the average. How do you find the average?
This is average. Average power is equal to work done over time.
How it's possible average same? It's no problem. Use the same formula
Of course, you are using the same formula.
because he said
The unit
average.
for the unit. What's that?
Because he said the average. No problem, right?
My brother, for finding the work done, you are taking the average torque, am I right?
Yes.
For this, you are just taking the average angle, am I right?
Yes, you're right.
So your power is nothing but delta W over T.
Yes, I understand.
Now, you can just see that the question is very, very important. You can just read the question. How much work is done on the wheel? That means you are doing the work on the wheel, am I right? That's what we are just using a negative sign here. If the work is done by the wheel, it is positive. Understand?
Understand.
The work done on the wheel is negative. Now you are going to take the value of the work done. So minus 29.9 over time is given in the question 1.5 second, minus into minus becomes plus. 29.9 over 1.5 gives you 19.9. What is the unit for power?
What?
Watt. Clear?
Yes. First, the minus you said about dimension in the question, right?
Yes, they clearly mention work done on the wheel. If it is work done by the wheel, then you have to put positive. But here they clearly mention work done on the wheel. Am I right?
The will, yeah.
Ah.
Yeah. Okay.
Okay. The last question. It is very easy. Only question is very bigger in size. But if you just write the answer, it is very smaller. Okay, read the question. Two discs are mounted on low friction bearing on the same axle and can be brought together so that they couple and rotate as one unit. Brother, you can see here, you have one disc. You have one disc and you have another disc on the same axis. That means your axis of rotation is here. Okay? Understand? They are rotating. When they are rotating on the same disc, the disc is rotating like this, and here another disc is rotating. After sometimes what will happen? Both discs join together. Both discs join together. Clear?
Clear.
Okay. Moment of inertia for the first disc is given. What is the value of moment of inertia for the first disc? 3.3 kilogram meter square. Its rotation speed direction is also given. The first wheel is rotating counterclockwise direction. What is the meaning for counterclockwise direction? This direction. Am I right? Am I right or not?
Yes, that's right.
You're
So
right.
it is moving counterclockwise direction. That means my omega 1i is how much? 450. Am I right? Open your mouth and just give your answer. I'm just giving the information only from the question, but you are just maintaining very small.
Yes,
You are
teacher,
just
you are right.
doing like this. You open your mouth and just give the answer. Okay. Now, second disc with the initial rotational inertia 6.6. So this is my second disc. What is my inertia? 6.6 kilogram meter square. And which direction it is rotating? It is also rotating in the counterclockwise direction. That means your omega 2i is 900 revolution per minute. Am I right?
Right.
Now, after it couples, what is the angular speed after couplings? Now, after it's joined, what should be its speed? Brother, you can see here, my first disc is also rotating in the same direction, in this direction. My second disc also is rotating in the same direction. So after it joined, which direction it will be rotating? It will be rotating in the same direction. Am I right?
Right.
So I'm going to write the conservation of angular momentum. What is the conservation of angular momentum? Initial momentum, which is equal to final momentum. Therefore, I1 omega 1i, which is plus I2 omega 2i, which is equal to, it's joined together. Am I right? Therefore, I1 plus I2 multiplied by omega final. Am I right? Now, we are going to find what should be the value of final omega. So you can just rearrange this question. Therefore, omega final, which is equal to I1 omega 1i plus I2 omega 2i divided by I1 plus I2. You have all the values. You substitute the value here, you'll get the answer. Am I right?
Yes, teacher. Right.
So I just write the answer only. 750 revolution per minute. No need to convert because they are not asking you to convert. Okay. Let's come for the second part. What is your second part, brother? Instead, the second disc is set spinning clockwise direction. Brother, when you come for the second part of the question, your second disc is rotating in this direction. Not in this direction, only in the clockwise direction. Now, what is the value, brother? I already give the information. If it is moving in the clockwise direction, negative value of omega. If it is moving in the counterclockwise direction, positive value. Do you remember that? We studied the concept in torque tau.
Get it, sir? We didn't hear you.
If it is moving, yeah, if it is moving in the clockwise direction, it will be negative. If it is moving in the counterclockwise direction, it will be positive. We already studied in chapter number 10. Do you remember
Yes, yes.
that?
Yes, doctor.
Now, in the second part of the question, what they said, the second disk is rotating in the clockwise direction. So what should be the value of this 900? It should be
Positive.
minus. Again, I am going to play with the same rule. Only important thing for the second disk in this place, what value you have to substitute? In place of 900, you have to put minus 900. Understand?
Yes.
Yes.
Now, when you just substitute the value, you'll get as minus 450 revolution per minute. Now, what should be the direction, brother? Could you please tell me the direction? Because in the first part of the question, both wheels are rotating in the same direction. So your coupling direction is also in the same direction. Am I right? But in the second
Yes.
part of the question, your first wheel is rotating in the counterclockwise direction, but your second wheel is rotating in the clockwise direction. Now, which direction it will be rotating after it coupling?
Clockwise because it's minus.
Because
It's minus.
not only minus, you can see the value. Here it is 450, here it is 900. Am I right? Which one is greater, brother?
900.
Your wheel will be rotating the clockwise direction because my second angular speed is greater. Am I right?
Yes.
So your wheel will be rotating in the clockwise direction. That will be the answer for the C part. Clear?
Clear.
Yes.
That answer is given here. I explained everything clearly. Take a paper and take a practice. Understand?
Yes, doctor.
Yes.
Okay. Any other question? My dear, you are going to write the quiz to this week. Am I right?
Yes.
Brother, you have
Yes.
many assessment. That means assignment is there, quiz 2 is there, and apart from that, your lab 2 grade will be also there. Am I right? So please, brother, please work a little bit harder. Then only you will get good marks, especially in the final grade. I'm talking about the final grade point of view. Try to get good marks in your quiz 2. We ask very easiest question. So please just go through your chapters 7 and 8 when you come for the quiz 2. Okay?
Doctors, I am worried about to solving. It will be easy, the question.
I said we are asking very easiest question.
Okay.
Read the question before you answer. That's the only thing you have to do.
Teacher, when we will take the assessment?
You mean
2.
assessment of quiz 2 or
Assignment.
assignment? Inshallah, by today I will submit. Inshallah, after the class, I have to make some correction, and by today I will upload. Which day you have to submit? 22nd of November. That means 2 weeks you have. This week and next week. Completely.
Okay, thank you.
teacher.
Doctors, the assignment about unit what?
From chapter 7, 8, 9, 10, 11.
Okay. 7, 8,
Up to
9.
this chapter. Till this chapter I have the question. Okay?
From 7 to
Okay.
10.
7 to 11.
7 to 11. Okay.
Yes, 5 chapters.
Okay, thank you, doctor.
Clear? So, brother, listen carefully, especially moment of inertia question. Just read the question. What type of structure is given? Then you have to take that formula for calculating the moment of inertia. Then only you have to calculate your angular momentum. I ask one question, so please do it very carefully. That question only carries 2 marks.
Doctor, do you think the second semester will be online?
I think second semester is also like the same. Here like that.
No.
Online.
Doctor.
Theory is
Doctor,
online. Theory is online. Lab should be on campus. Yes.
quiz 2 will be in the class time, 9
Yes,
a.m.
brother, listen carefully. Quiz 2 exactly will be in your class time. Inshallah, Wednesday we have one period. Am I right? Am I right or
Yes,
not?
we have the.
Yes, you are right.
Yes, teacher of
But in that time, you are going to write your quiz 2. I don't want to conduct the quiz exam after 3 or 4 because many students they are just saying they need the quiz exam in the evening time. But I don't like because there may be chance for missing the exam. Better we can just consider our quiz 2 during our class time. Okay.
Better. It's better, Doctor. Thank you.
Okay, brother, please prepare well for your quiz 2. It will be very easy. Clear?
Okay, Doctor,
Okay.
I ask you about chapter 7.
Right now?
No problem.
No. Tomorrow. Tomorrow we have an office hour. Am I right?
Okay.
Please come and I will explain.
Okay.
Because I have one more class, brother. I have one more class after this
No
class.
problem. Thank you, Doctor.
No problem. I will explain. Inshallah, tomorrow you have office hour. Am I right?
Yes, inshallah.
Inshallah, I will explain.
Thank you, Doctor.
Okay, brother. See you.
Thank you.
Assalamu alaikum.
Teacher.
Walaikum salam. See you.
See you.